Hello, you absolute legends. My name is Eric J. Choi, and I'll be going over explaining video 9.1 that goes on about how to draw the PV diagram, calculate the work, and also find the heat efficiency for a heat engine. And okay, jumping right into the problem. So this shows a heat engine going through one cycle. The gas is diatomic. The masses are such that when the pin is removed in steps 3 and 6, the piston does not move. And draw the PV diagram, figure out how much work is done per cycle of this cycle, and what is this engine's thermal efficiency. So first off, we have to draw a PV diagram, which we can do by reading these steps right here and paying attention to the locking pin, keeping the volume constant or not constant between each step, or keeping the pressure constant or not constant. You can see what I mean right here. So going from phase 1 to 2 to 3 to 4 in a cycle, as shown in the diagram right here. From steps 1 to 4, denoted by the red 1, the volume is kept constant and the pressure was increased to 3 atmospheres. And you can see that right here. The locking pin is still in place, but it got heated up to 3 atmospheres of pressure. Now, I won't keep scrolling back and forth between these, so I'm pretty sure you'll have a copy of this on the Physics 40B website, and I'll continue explaining the rest of the steps. Steps 2 to 3, the volume is increased to 100 while pressure is constant. The pressure is decreased back down to 1 atmosphere while a constant volume, and the volume is decreased to 50 while the pressure is constant for steps 2, 3, and 4 respectively. Sorry I'm rushing through, but this isn't the meat of the problem that we should be focusing on. So, B asks for how much work is done per cycle. Now, if you know the little trick to it, the work is actually the area of this square that we drew right here. So basically, the change in pressure or volume here times the change in pressure here. Exactly the same way as finding the area of a square. So that plays into the work formula of work is equal to PV, except it's delta P and delta V. Using our given calculations that we got from each step, we find that delta P is 2, delta V is 50, and some conversions that we should know while solving the problems is 1 atmosphere is equal to 1.01325 times 10 to the 5th pascals. Damn, that's a mouthful. And 1 centimeters cubed is equal to 10 to the negative 6 meters cubed, which you can see right here. Ultimately, we roughly get an answer of around 10 joules. Now, C asked us for the thermal efficiency. If I'm correct? Yes, it did. Okay. So, first off, we have to figure out this equation right here. Because this is our end goal, we first have to figure out this portion and this portion, as shown right here. First, we have to figure out the work from steps 2 to steps 3, which is found by doing work is equal to PV, and during that step, pressure was kept constant, so all we have to work with is the change in volume between steps 2 and 3. So, 3 atmospheres times the units that we had before ultimately ends us up with around 15 joules. Now, we come to the tricky part of the problem. We can't actually find T in what we've been given so far, but we can find a ratio of it instead. So we can guesstimate how much it is and use that guesstimate to solve the problem, as shown right here. If we isolate N out and move it to the other side, we get PV is over RT, and we can find the ratio of T by arranging the pressure, volume over temperature of one point of the cycle and equate it to another point of the cycle, as shown right here. I know I wrote P2 V2 T2, but I did that for more of a uniform equation. It actually represents the third point of the top right corner in the cycle, rather than the second phase. So plugging in our known values, we ultimately get this format. And as we simplify down further, we find that the temperature at T2 is equal to 6 times the temperature at T1. Or rather, this is still phase 3 if you're confused at this point. Now that we find 5T1 is equal to delta T, we can plug that into our delta U equation and ultimately find that it is equal to PV times 25 over 2 by plugging in our known values, like CV is equal to 5 over 2R from our lectures, until we finally end up with a final answer by plugging in our known values as 63.3 joules. Sorry if I went a bit over time, but there's a lot to explain this problem, and I hope you guys understood it. You absolute legends. Have a nice day.